Okay, let's try to wrap up this chapter. In this video, we're going to start off by talking about hydrates. What is a hydrate? It is a compound that has water attached to it. Like the water is just associated with the compound. It isn't covalently bonded to it. It's just an association. So you normally see hydrates with a little dot between the actual compound and the water molecules. So for example, you have something like this, FeSO4, and then there's a dot. I don't know if you can actually see the dot in the video, but let me try to make it big. Dot, and then 7H2O. So how do we name this? Well, first ignore the water and name this the proper way, the way you would. You can't say iron sulfate. Why not? Because iron is a variable charge metal, as we've learned before, and so you have to decide which iron is this. So remember the technique I taught you guys, dotted line, and you see that the sulfate, you've got this memorized, sulfates are always -2. So this is -2, so this has to be +1. I only have one of them. So this would be iron, Roman numeral 2, sulfate, and then you tell me how many waters there are. Remember the prefixes. 7 is hepta, so you'd say heptahydrate. Okay, that's the proper name for something like that. Well, what if I give you the name of a compound? Calcium chloride hexahydrate. Now you have to write the formula. Well, calcium chloride, you should know how to write that. Calcium, you know that calcium is 2 plus, chloride is -1, crisscross, just like we learned in previous videos. So it's CaCl2. Okay, dot. What is hexa? Hexa is 6. So dot 6H2O. Okay, hydrates are pretty straightforward. All right, so I was looking through the what you need to know list. I think I've covered pretty much everything, and now we're left with topic number 14, which is be able to write and balance chemical equations. What do I mean by write? I mean write the correct formula. So if I give you the equation in words, you should be able to write the correct formulas and then balance it. And what is balancing? That's the method of putting coefficients, a number in front of each substance in the equation, so that you could fulfill the law of conservation of mass. And what is the law of conservation of mass? The mass of the reactants has to equal the mass of the products. Okay, so basically, if you're going to have 7 carbons on one side, you better have 7 carbons on the other side. If you're going to have 5 oxygens on one side, you better have 5 oxygens on the other side. Okay, all right, so here are some words here. I have calcium phosphate, so I'm going to say calcium phosphate. Calcium phosphate reacts with nitric acid. So that means you have to be able to write down the formula of calcium phosphate and nitric acid to produce. Okay, what are the products? Calcium nitrate. Calcium nitrate, oops, can't spell. Calcium nitrate and phosphoric acid. So this is an example of a chemical equation in words. And so now you have to write the formulas before you balance it. All right, calcium phosphate. You know that calcium is +2, and you know that phosphate is -3. How do you know that? Well, you know calcium is a group 2A metal. All group 2A metals are +2. Phosphate you have memorized. That is one of your polyatomic ions you should know. So crisscross, and so you have Ca3PO4 2. Okay? Plus nitric acid. We just did nitric acid in the previous video. HNO3. That's nitric acid. Okay. If it was nitrous acid, it would be HNO2. Okay, to produce calcium nitrate. Calcium, remember, is +2. Nitrate is NO3 minus. Crisscross, so you've got CaNO3 parentheses 2. So this is calcium nitrate. And phosphoric acid, H3PO4. Again, we just did acids, ternary acids in the previous video. Okay, so now I wrote correct formulas. That's the key part of balancing, is to first have correct formulas. If you don't have correct formulas, honestly, you could try to balance forever and it just won't get balanced. So you have to write correct formulas first and then we balance. Now, sometimes on exams, I already give you the correct formulas and all you have to do is balance, but sometimes you have to write the formulas yourself. Okay, so what do? If you remember from intro chemistry days, it's easier to begin with what I call the busiest compound. This one looks like it's got a lot of stuff going on, so let's focus on this one. Can you see that you have 3 calciums here? Well, let's make sure we have 3 calciums over here. How do we make 3 calciums over here? We don't mess with the subscripts at all. We put numbers in front. See, I need some space here. So make this a small arrow. I'm going to use the blue marker so you can see the numbers. So because I have 3 calciums, I'm just going to put a 3 over here. That immediately tells me that on this side I have 3 calciums and on this side I have 3 calciums. Okay, can you see over here that you have 2 phosphates? This parentheses is telling you that this 2 multiplies this whole phosphate by 2. So I have 2 phosphates on this side. I need 2 phosphates on this side. How do I put 2 phosphates on this side? I put a 2 in front of the H3PO4. There's really not much space. Sorry about that, guys. I'm just going to put a 2 right here. So that means I have 2 phosphates, 2 phosphates, 3 calciums, 3 calciums. Good. Whenever you see polyatomic ions in a chemical equation, just balance the polyatomic ions as an intact unit. All right? Don't sit and try to balance the phosphoruses by themselves and the oxygens by themselves. The whole thing as one unit, it balances beautifully. All right, so now I take a look. 3 times 2, this means I have 6 nitrates, because this has 2 nitrates, and I multiply it by 3, that's 6 nitrates. And it says here I have 6 hydrogens. So 6 hydrogens and 6 nitrates. If I put a 6 right over here, that will give me 6 nitrates on this side. I have 6 nitrates on this side, 6 hydrogens on this side, 6 hydrogens on this side. Beautifully balanced equation. What does this actually mean? It means that for every 1 calcium phosphate, it will react with 6 nitric acids to produce 3 calcium nitrates and 2 phosphoric acids. You can think of it as molecular quantities or molar quantities. We're going to get into moles in the next chapter. But, this could say 1 formula unit of calcium phosphate reacts with 6 molecules of nitric acid to produce 3 formula units of calcium nitrate and 2 molecules of phosphoric acid. Okay? Or as in when we get into chapter 3, 1 mole of this will produce 6 moles, 1 mole of this will react with 6 moles of this to produce 3 moles of this and 2 moles of this. Okay, let's do a few more balancing of equations, but this time I'll give you the equation and we'll balance them together. And I'm going to introduce to you guys the fraction technique. You may have learned it in an intro chem class. I know I teach it to all my intro students, so hopefully you learned it. These are hydrocarbon combustion problems. This is propane gas. This is the stuff that you have in your grill. Whenever you have an organic compound and you burn it in oxygen, the 2 products are always going to be carbon dioxide and water, assuming there's enough oxygen there. Okay, we start with that busy compound, this guy over here. We have 3 carbons, so we put a 3 here. Got 3 carbons. We have 8 hydrogens. So you put a 4 here. Why is it 4? Because 4 times 2 is 8. We got our hydrogens done. The last thing you want to balance is an element that's by itself. So this oxygen by itself is going to get the last coefficient. So let's count how many oxygens are on this side. We've got 3 times 2 is 6, plus 4, we have 10 oxygens on this side. So we want 10 on this side, so what do? We just put a 5, and you're all set. For this one, you don't have to use a fraction technique. It works beautifully. Now let me show you one with a fraction, that you'll have to use a fraction. So C4H10, this is butane. That's the gas we have in our Bunsen burners at school, in our lab. If you take butane and you burn it in oxygen, you're going to get carbon dioxide and water. Okay, busy compound. Let's focus on that. We have 4 carbons. Let me use the blue pen, blue marker. All right. So we have 4 carbons, so we're going to put a 4 here. We got our carbons done. We have 10 hydrogens, so we're going to put a 5 here. 5 times 2 is 10. Great. Now let's count how many oxygens. Remember, the oxygen by itself is the last thing you're going to balance. So let's count how many oxygens we have over on this side. 4 times 2 is 8, plus 5, that's 13 oxygens. So we want 13 oxygens on this side. Okay. If you put a 13 here, you end up having 26 oxygens. Can you guys see that? 13 times 2 is 26. We don't want 26. We want half of that. So what you do is you say divided by 2. I want 13 divided by 2. But you can't leave a fraction in these equations. You'll be able to leave fractions later on in the semester when we're doing thermochemical equations, but not yet. So how do I get rid of the fraction? You multiply the whole thing by 2. So we can get rid of this denominator. So this was a 1, now it becomes a 2. 2 times 13 over 2 is 13. 2 times 4 is 8. 2 times 5 is 10. So the coefficients are 2, 13, 8, and 10. And that's the fraction technique. Okay? Plenty of practice in your book, plenty of practice in your homework. The only way to become really, really good at balancing equations is to practice. I just showed you a few examples, but it's up to you to practice with all of them. Okay, we are done with chapter 2, and the next video will start us on chapter 3.